Okay, welcome. We're here with time and date following this total lunar eclipse. Hello, Graham.
Hello, Anna. And, first of all, it is great to be back with you on timeanddate.com. And Anna, can you believe that 6 months have passed already since we signed off at the end of our live coverage of the great American total solar eclipse back in August last year? 6 months have gone by, and the moon and the earth and the sun, they are coming into alignment again to give us another eclipse today.
And what are we in for today?
Well, today is all about the moon. The moon takes center stage today. In the past, the moon played such a central role in the life of humans. Every big event was planned around full moons and new moons. It really played this critical role in the life of humans. But, today in the 21st century, we tend to take the moon for granted. To be honest, we often forget it's there. But today is one of those days that just reminds us to look up and to appreciate the moon, because today we have three things happening. We have a supermoon, we have a blue moon, and we have a blood moon.
Yeah, and we're going to get further into these things and explain what they are later on. But who's going to be able to see this?
If we can pull up the eclipse map.
Yeah, we've got it up now.
We've got it up now. Okay, so what we're looking at here is, first of all, in the middle of the screen, we have this dark U-shaped area. This includes China, Japan, Australia, Western Pacific, and Hawaii. This area can see all of today's total lunar eclipse. At the sides of this screen, we have this white area. This is South America, most of Africa, and Western Europe. These areas cannot see any of today's total lunar eclipse. And then we have these bands on the left side and on the right side. Over on the right side, we have these bands going across North America. This is where the eclipse is going to be visible as the moon sets. This is in the morning of January 31st. The moon is going to be setting during one of the stages of today's lunar eclipse. Over on the left-hand side, we have the bands that are going across Eastern Europe and Central Asia. And these are the areas where some stages of the eclipse will be visible as the moon rises. And the moon will be rising in the evening on January 31st. So on the left-hand side, that's where the eclipse is happening as the moon rises. On the right side, that's where it's happening as the moon sets.
And we'll be showing from different locations today, mainly from our friends at Perth Observatory. But we'll also be showing a little bit from LA and a little bit from NASA's stream, depending on if there will be clouds in front of the moon. Right, Graham?
Well, that's right. Yes. So we've got some great locations today. You should say that I'm here in Japan,
yes.
which is in a perfect location in terms of time zone, because it is 8:45 in the evening here in Japan. It is the perfect time for an evening eclipse. It's a really prime time lunar eclipse. The only problem in Japan, the thing that's not perfect, is the weather. We have had a very crazy winter in Japan, some record snowfalls in Tokyo. And at the moment, the moon is doing a great job and is finding a little bit of clear sky in Japan, but
awesome.
clouds are forecast for later. There's some more snow forecast for later, so we'll have to see what happens.
But I see we're coming up here to the start of the partial eclipse. We should get up some images from that.
So the partial stage of the eclipse will be beginning in about 1 minute's time. And if we can have a look at one of the feeds of the moon, perhaps if we can look at the feed from the Perth Observatory, we can take a look at the start of the partial eclipse. So a lunar eclipse has various stages, and now here we are looking at a live feed. This is coming from the Perth Observatory in Los Angeles. The Perth Observatory, it's an iconic observatory in Los Angeles. It's on the slopes of Mount Hollywood, outside Los Angeles, and they're providing us with this wonderful picture here of the start of the partial phase of the eclipse.
And what will we see? And are we starting to see it?
We are starting to see it right now. We can see that on the left-hand side of the moon, as we are looking at it on the screen here, we can now see this dark area that is starting to move across the surface of the moon. And this dark area, we are looking here at the shadow of the Earth. At a total lunar eclipse, we have the moon, the Earth, and the sun perfectly in alignment. And the Earth's shadow projects out onto the moon. And what we're looking at here is the Earth's shadow moving across the surface of the moon.
And it moves slowly, right?
Now, it all moves very slowly, yes. So, I mean, anybody who was watching the solar eclipse in the USA last year, we know that solar eclipses around totality, everything seems to move very fast. It's all down to seconds. With a lunar eclipse, everything feels a lot slower. Everything happens in a much more relaxed pace. What we're actually looking at on the screen at the moment, we're looking at the Earth's shadow. We're actually looking at two different shadows.
And we have some illustrations for that. So if we can get those up, and we'll remove me and you'll be on your own, Graham.
Okay. So if we can get up, if we can put up the illustrations that show the Earth's shadow. The thing with the Earth's shadow is that it does have two different parts, because the sun is not just a point of light. The sun is a big ball of light, and this does mean that there are two different shadows that the Earth produces. There is a light outer shadow and there is a dark inner shadow. Now we can see on the diagram there, we can see these two different areas of the shadow. The light outer shadow, the name for this is the penumbra. And really the best way to think of the penumbra is actually to imagine that you are standing on the moon and looking back towards the Earth and towards the sun. Now, as the Earth moves across the sun, this is all from the point of view of somebody standing on the moon. As they look towards the Earth and sun, as the Earth moves across the sun, it starts off with a partial solar eclipse. The Earth just blocks out a small part of the sun. Now, when that happens, the person standing on the moon is not receiving all of the light from the sun. They're only getting 90% of the light from the sun. And as the Earth continues to move across the sun, that partial eclipse gets more and more. So 80% of the sun, of the sunlight is reaching. And then it's only 70%. And then it's only 60%. And gradually the whole of the sun gets blocked out by the Earth. So when that is happening, that person is standing in the penumbra of the Earth's shadow. The sun is not completely blocked. Only some of the sunlight is blocked. And so that's producing just this very light outer shadow on the moon. Sorry, Anna.
I was interrupting you there. We're showing images from Australia now. The moon is rising up between the gum trees in Australia. We'll get that image up. Can you see it now?
Right. Yeah. Okay. I can see that image now. Yeah. Yes. Okay. Yeah. There it is.
So that's the moon rising up through the gum trees. We still have graphics for Los Angeles staying there, but we're in Perth, Australia at the moment, showing the moon rising up in Australia. And this is going to be our main feed. We've got, we're going to show pretty much the whole eclipse there, right, Graham?
That's right. The Perth Observatory in Western Australia, they are going to be, bringing us some great pictures of the whole eclipse through to the end of the very final partial phase later on today. So Perth is in Western Australia. It is just in those bands that we were looking at on the eclipse map earlier, because the moon is rising just as the partial phase is beginning. So that's why we're seeing the moon through these trees here in Perth, because the moon is just rising up above the horizon. But it'll be getting up above these trees fairly quickly, and then we're going to be having some great views.
Yeah, so we're going to take a break. Make sure to have a look at us at timeanddate.com/live, where you're going to get continuous updates on what's happening with this lunar eclipse. We'll talk to you soon, Graham.
Okay, talk to you very soon. of the total lunar eclipse of January 2018. And we are looking here at live pictures from the Perth Observatory in Western Australia. And we are into the partial phase of the eclipse. The dark part of the Earth's shadow is now starting to move across the surface of the moon. As we look here in Perth, the dark shadow started from around about the 5 o'clock position on the face of the moon, and this dark area is now proceeding to move across the whole of the moon. And we can see in the graphic in the bottom of the screen there, we can again see these different shadows that the Earth produces. There is the light outer shadow. This is called the penumbra. When the moon goes into the penumbra, it's just a very subtle, very light shadow that is projected onto the moon. Very difficult to see any difference. As we look at these pictures from Perth, the silver gray area, the top half of the moon, that is in the Earth's penumbra as we look at it right now. But it's very difficult to tell any difference from a normal moon brightness. The big difference comes with the umbra. This is the dark inner part of the Earth's shadow. And when that gets onto the moon, we can see the difference very clearly because we can see this big black area moving across the face of the moon. And you know, really I think one of the best ways to think about a lunar eclipse is actually to think of the Japanese word for a lunar eclipse. I'm here in Japan for this coverage, and the Japanese word for a lunar eclipse is ge shoku. Now, ge refers to the moon, and shoku refers to eating. This is the Japanese word for a lunar eclipse is moon eating. It is as if something is eating away the moon, and that's what we are looking at on these pictures from Perth at the moment. The bottom half of the moon there just seems to be disappearing as the dark part of the Earth's shadow moves across it. Now today on timeanddate.com, we have these pictures from Perth. We also have the pictures from the Griffith Observatory in Los Angeles. And this is a very interesting, going to be very interesting for us because they are giving us two completely different perspectives on this lunar eclipse. Now, the lunar eclipse is visible from half of the globe. Anyone on the nighttime side of the Earth at the moment, anybody will be able to see this lunar eclipse happening. We're all watching the same event as the Earth's shadow moves across the moon. But the orientation of the moon is different for different observers. Now we've switched to our feed from Los Angeles, and you can see that the shadow, it's the same amount of the moon that has been eaten away, but the shadow looks like it's coming from a completely opposite direction. And in a sense, it is, because Los Angeles is in the northern hemisphere, Perth is in the southern hemisphere. Remember, in America, in Los Angeles, this is all happening as we build up to moonset. This is all happening in the morning. This is early morning in California. The moon is coming down towards the horizon and will be setting in a few hours. In Perth, the moon is rising. It's early evening there. The moon is coming up from the horizon. And these differences mean that the orientation of the moon is different. We're seeing the moon at a different orientation. So it looks like the Earth's shadow is approaching from a different direction. But the key thing here is we are watching exactly the same event. It is exactly the same shadow. We're just looking at it from different perspectives and from different angles. So we're going to leave you. Watching these great pictures from the Griffith Observatory in Los Angeles. Don't forget, if you're taking, if you're out with your camera, if you're taking any pictures of this, then please do send them through to us here at timeanddate.com, and we'd love to share your images with the world. If you go to, if you look on our live page, then we have details there of how you can send your images to us. So please do take part in this and share your images with us. And also keep up to date with everything that's happening on our live blog page at timeanddate.com/live. And we will be back with you in a few minutes. Thank you very much. and welcome back to our live coverage of this total lunar eclipse on timeanddate.com. We are continuing to watch the partial eclipse as it moves across the surface of the moon. Now, a lot of people do ask the question about why the Earth's shadow is not a sharp shadow as it moves across the moon. We can see on the pictures here that the edge of the Earth's shadow is a little bit fuzzy. It's not a very sharp shadow that goes across the center of the moon there. Now, the reason for this is that we are looking at two different shadows here, and there is a gradation between these shadows. The dark area we know is the dark umbra, the inner part of the Earth's shadow. The silver gray area at the top of the screen, as we're looking at the moment, that is also a shadow. That is the lighter part of the Earth's shadow. That is the penumbra, that silver gray lighter area. But here is the thing, that we're actually looking at we're looking at a gradation between the dark shadow and the light shadow. So the very dark area, that is 100% Earth's shadow. There, the sun is completely eclipsed. If you're standing on the moon, then the sun is completely blocked by the Earth. If you move just a little bit into the light area, then if you're standing on the moon, you would be looking at a partial eclipse. You would see just a little bit of sunlight, but not very much. And as you move further across, further into that lighter area, more and more sunlight is coming through. So we're looking at the dark area is 100% Earth's shadow. And then as we go into the lighter area, it's moving down 99%, 98%, 97%, and so on. And more and more light is getting there. So that gives us this fuzzy edge to the Earth's shadow. It's not just shadow and no shadow. It is this gradation that goes across the moon's surface. And as we look at it now, we're now seeing what looks to be a very strange shape for the moon. We are very used to seeing crescent moons around the time of a new moon, at sunrise and at sunset. We often see these beautiful crescent moons. But the crescent moon we're looking at the moment is a very strange looking crescent moon indeed. It's not like any crescent moon that we ever normally see during the course of a lunar month. And this is because the Earth's shadow is now covering so much of the moon. It's getting right out towards the right-hand side of the moon as we look at it, that we're just left with this crescent shape that does look very odd and very strange to our eyes because it's so unlike the crescent moon that we're used to seeing as part of the normal lunar month. So things are starting to look very strange with the moon now. This is a view of the moon that we only get during total lunar eclipses. Now, at the beginning of our coverage today, we mentioned some terms. We mentioned things like supermoon and blue moon and blood moon, and we still need to explain and talk about all these different terms. They've been used a lot by the media during the build-up to this lunar eclipse. We are going to be back shortly, and we are going to start looking at some of these terms, some of the history behind the words that are used to talk about the moon. And just a reminder that we are about 22 minutes away from the start of the total phase of this lunar eclipse. So we will be back to continue our live coverage of this lunar eclipse on timeanddate.com in a few minutes. And don't forget to keep an eye on our live blog page as well. See you in a few minutes. Welcome back to the live coverage of the total lunar eclipse on timeanddate.com. Now, some people have been wondering what has happened to Anna. And we should say that Anna is still with us. She's in the control room at the Time and Date HQ in Stavanger in Norway. And Anna and the rest of the team at Time and Date are doing a fabulous job getting us these live pictures of the eclipse. They're also updating our live blog page with some great images from around the world as well. So they're all there working away, bringing all these fantastic pictures to us of the eclipse. And if we look on the screen now, we're looking at these pictures from the Perth Observatory in Western Australia. And you can see that things are starting to get very interesting now. We are at 12:38 UTC, which means we are 10 minutes away from totality. Totality is where the whole of the moon is covered by the dark part of the Earth's shadow. And as we look at these pictures now from the Perth Observatory, we can see that only a tiny part of the moon is still in that light outer part of the Earth's shadow, and the dark inner part of the shadow is now covering nearly the entire moon. Nearly the whole moon has been eaten away. But it's not quite as straightforward as that, because now if we look at the dark area of the moon, we can start to see that it's not completely dark after all. Now, what they've done in Perth is that they've increased the exposure on their camera. That's why the lighter part of the moon is looking a lot brighter now. It's looking very white because they've increased the exposure, and this means that we can see what is now going on in that dark part of the moon, which is completely blocked from the sun. It's in the dark part of the Earth's shadow. But as we look at it, we can see that it's not completely dark. We can see that it is slowly beginning to take on a slightly reddish tint. And we're going to see this much more clearly in about 8 minutes when the whole of the moon is within the dark part of the Earth's shadow. At that stage, we will see this much more clearly, that the surface of the moon takes on this reddish tint. And this is where one of the terms that we mentioned at the beginning of the program comes in. This is where people talk about the blood moon, because during totality, the surface of the moon takes on this reddy, browny, orangey color. And the question is, why does the moon turn red during totality? Well, in fact, an even more interesting question is why can we see anything at all? Because we're saying that this is the dark part of the Earth's shadow. We're saying that the sun is completely blocked by the Earth. So how is it possible that there's any light at all for us to see on the moon, let alone red light or orange light? Well, for this, we've got to think about our planet. We've got to think about the Earth. So the Earth is a big rocky planet. It's about 13,000 kilometers across. And if you're standing on the moon looking at the Earth is much bigger than the sun. So as the Earth moves across the face of the sun, it completely blocks the sunlight from reaching the moon. But here's the thing. The Earth is surrounded by an atmosphere. This is this layer of air, which is about 100 kilometers thick. And this atmosphere does these very interesting things to the sunlight. One thing it does is that it bends the sun's rays around the Earth and bends them towards the moon. This is called refraction. This is the effect we see when we have a glass of water and we put a straw in it, and the straw looks bent. When rays of light move from one medium into another, then they bend, they change direction. And as the sunlight hits the Earth's atmosphere surrounding the Earth, sunlight is bent and it's sent towards the moon. But the atmosphere does something else as well. As well as bending the light, it also filters out the blue color from the light. This is something that is called scattering. The blue light is filtered out. And it's the reason why when we look up at the sky in the daytime, we see a blue sky. It's because the blue light is being scattered out of the sunlight. So we put these two things together. The atmosphere is filtering out the blue light, and it's then bending the light towards the moon. And because the blue light has been scattered away, it's been filtered out, the wavelengths of light that are left are red in color. So the atmosphere is bending red light towards the moon. And that is what gives the moon its reddish tint during a total solar eclipse. If we go back to the image from Perth, we might just be able to have another look at that. We are going to come back. We will actually come back in a few minutes with the updated images from Perth. We are just a few minutes away from the start of totality. So please come back to us here in just a few minutes' time. Thank you very much. And welcome back to timeanddate.com and our live coverage of the total lunar eclipse, which is just 2 minutes away from totality. In just 2 minutes, the whole of the moon will have moved within the dark part of the Earth's shadow. And as we look at the latest pictures from the Perth Observatory in Australia, we can see that there is now just the very tiniest fraction of the moon that is still being bathed by sunlight in this lighter part of the Earth's shadow, and the rest of the moon is now taking on. We can now see very clearly this reddish brownish tint that the moon is taking on, and we are about 1.5 minutes away from the beginning of totality, and then we will have a fully red moon. And of course, we call it a blood moon. It's not an official astronomical term. In fact, the sort of color we're looking at here is actually not a very good blood color. I think if a person's blood is actually this tint, then that's probably not a very good sign. But it does give us the idea of this reddy, browny, orangey tint that we get on the moon. And we are now under 1 minute away from the start of the total phase. Now, if we just think at this point what it would be like to be standing on the surface of the moon right now, looking back towards the Earth. So if we were standing anywhere on the moon, on the side of the moon that we can see now, the whole of the moon there is in the dark part of the Earth's shadow. If we were standing there looking back towards the Earth, we would see the nighttime side of the Earth facing us, and behind the Earth, but blocked from view, there would be the sun. Now the sun, we can't see it. It's hiding behind the Earth, but we are still getting rays of light from the sun that are being bent towards us by the Earth's atmosphere. What we would see, in fact, is the dark nighttime side of the Earth surrounded by a red halo. We would be looking at the Earth's atmosphere glowing red, and it would be that red glow that would be bathing us in the red light that we can now see very clearly, covering the whole surface of the moon. Now, of course, the interesting thing is, if we were on the moon, looking towards the Earth, looking at this red halo of light, we would actually be looking at the interface between the dark nighttime side of the Earth and the bright daytime side of the Earth. Because pointed towards us on the moon would be the nighttime side of the Earth. Pointing away from us, facing towards the sun, would be the bright daytime side of the Earth. We wouldn't be able to see that from the moon. But we could see the boundary between these two areas, this red glow where the nighttime meets the daytime. Now, of course, we do have a name for the time that daytime and nighttime meet. We call it sunrise, or we call it sunset. And essentially, the red halo that we would see surrounding the Earth, we would actually be looking at all of the sunrises and all of the sunsets taking place on the Earth right now. We'd be seeing them all at the same time, every sunrise and every sunset happening on the Earth. And really, that's what we are looking at on the screen right now. This red color, this orange color, this is the red and orange glow of all the sunrises and all the sunsets that are taking place on the Earth at this moment. So we are into the total phase of the eclipse. This will be lasting for about an hour and 20 minutes. Totality will end at 14:07 UTC. So we have over an hour to enjoy this this wonderful tinted moon, and we will continue to bring you these great pictures from the Perth Observatory. We'll continue to put your photos and your images on our live blog page as well. And we will be back with you here in a few minutes' time. So we'll see you soon. Welcome back to our live coverage of the total lunar eclipse here on timeanddate.com. And things are getting really exciting here. Things are getting very exciting in the sky. We can see the latest images here from the Perth Observatory in Western Australia. And the moon has taken on the most fantastic shade of pinky red there. It's looking absolutely wonderful. We do have to say that we are enormously grateful to the amazing team at the Perth Observatory who are supplying us with these beautiful images today. In particular to Matt and Roger, who have been so busy over the past few days testing equipment, trying different setups. They're doing all of this out in the Australian bush. There's very little power. They're having to do things with batteries. They're having to change batteries every now and then. They've got their hands full with so many things, but they are getting us these spectacular pictures of the moon. So yeah, we are hugely grateful to the team there at Perth Observatory. We've also been having some excitement here at timeanddate.com. It's been a really busy day for our website here, and we think that some of you may have had some problems just recently getting onto our website and getting onto our live page. We're sorry about the problems we've had, but we are back up and running now. As I say, it's been exciting. We've had so many visitors coming to the website, but the website is back up and running. The live page is back up and running. So we're all there. By the way, in the live blog, we do have some pictures in there of Matt and Roger at Perth Observatory. We have some pictures of them working away on the telescope and getting us these pictures. So do have a look at our live web page at timeanddate.com/live. So wonderful images from Perth. Now I'm here in Japan. I'm in central Japan, about 50 kilometers northeast of Kyoto. And sadly, in Japan, we've had all kinds of weather problems here today. Earlier on this evening, when the full moon rose, when we had the full moon at full brightness before the eclipse began, the moon was doing a very good job of punching its way through some light cloud cover. And we did have a great look at a beautiful rising full moon this evening. However, at this point of the eclipse, at totality, the moon has taken on this red color. The moon is also a lot dimmer and a lot darker than it was. We saw at the end of the partial eclipse phase when Perth Observatory was having to turn up the exposure on its cameras in order to give us the first hint of this red color. The moon is a lot dimmer. And here in Japan, unfortunately, we have now lost sight of the moon. It's not bright enough to force its way through the cloud cover that we have here. But there is one amazingly beautiful thing that is happening here in central Japan. If you go outside and have a look up, you can see some clouds, but you can see some pinky red clouds. We have pinky red clouds above us in central Japan. That is the light from the blood red moon reflecting onto the clouds. And actually, if we think about this, it's actually rather wonderful. We have light that has come from the sun. The light has then been refracted and bent and filtered and scattered by the Earth's atmosphere. It's then been sent towards the moon, and then it's been reflected back here to us on the Earth again. So these pinky clouds we have in Japan, that is sunlight that has been bent through the Earth's atmosphere. It's been sent to the surface of the moon and then reflected back to the Earth again. A wonderful journey through space, giving us some beautiful clouds here in Japan. And we are now getting very close to the maximum stage of the eclipse. The eclipse maximum is coming up at 1329 UTC. And we are now here at 1325 UTC. So we are about 4 minutes away from the maximum eclipse. This is the point where the Earth is the deepest into the umbra. It's the furthest the whole moon travels into the dark part of the Earth's shadow. And that's where we really see the very strongest tints of red and orange. We're continuing to have a look at these great colors that are coming to us from the Perth Observatory. You know, one of the fascinating things about total lunar eclipses is that we never know exactly what kind of tint the moon is going to turn. Remember, this is all air that has been refracted and filtered by the Earth's atmosphere. We never know exactly what condition the Earth's atmosphere is going to be in. It depends on how much cloud cover there is on the part of the Earth's atmosphere that the light travels through. It depends how many particles and things we have in the atmosphere. Things like volcanic eruptions, for example, send all kinds of particles into the Earth's atmosphere that filter and scatter light to different degrees. So we never know exactly what color the moon is going to turn until the eclipse happens. And here is something that in fact everybody can help with. Because about 100 years ago, a French astronomer, André-Louis Danjon, he came up with a scale of different colors to describe the different tints that a moon can become during a total lunar eclipse. He came up with a scale of 5 different shades. We call this the Danjon scale. And every lunar eclipse is different, and every lunar eclipse can be given a number to describe what color the moon turns during that eclipse. And we can see on the screen now, we can see these different shades. It starts from 0 on the left-hand side, and it goes through to 4 on the right-hand side. And we can see that on the left-hand side at 0, this is when we have a very dark moon, almost an invisible moon. We don't have a very strong tinted color. The moon just goes very dark and becomes almost invisible. And then we move through the different shades until we get to the right-hand side, to the number 4. And this is where we have quite an orangey, yellowy moon. It's a lot closer to that normal bright moon color that we see. So in this case, it's a much brighter moon, and it's much closer to the familiar moon color that we see. Now we are around about, I think, half a minute away from the maximum eclipse now. So this is the middle of totality. This is the moon is now at its deepest point into the dark part of the Earth's shadow, and if we just get if we could just actually get the Danjon scale back onto the screen there, this is a good moment to have a look at this and to have a judge at what color you think the moon is. So we have these we have this scale of 5 different shades from the very dark 0 on the left through to the very bright yellow orangey on the right. The question is, which of these tints best matches the moon that we're looking at here? Now, of course, this is very subjective. And here, of course, we are looking at images through a telescope in Perth. Of course, there's exposures and there's all kinds of settings on the camera there, and that's all changing the color slightly. So different people looking at the moon through different equipment and looking at the moon in different places on the world can all come to different views on what the number should be for this lunar eclipse. But here is a challenge for the timeanddate.com community. As well as sending us your pictures and images to the live page, it would also be great to know what color the moon is as you see it from your location. So again, we're going from a very dark moon from 0 right the way through to a very light yellowy orangey moon, number 4. We've got a kind of a very reddish moon at number 3, and then getting slightly duller moons at 2 and 1. What color do you think the moon is? What Danjon number would you assign to this total lunar eclipse? We would love to hear your thoughts on this on our live page as well. So we will leave you with these pictures of maximum eclipse, and we will be back with you very shortly. Thank you very much and see you soon. Welcome back to timeanddate.com's live coverage of this total lunar eclipse. We are at 13:43 UTC, and so we're about half an hour away from the end of totality, this total phase of the eclipse, where the whole of the moon is in the darkest part of the Earth's shadow. In about half an hour, we will begin again with another partial phase. The moon will begin to move out of the darkest part of the Earth's shadow back into the lighter part of the Earth's shadow, and we will see the same thing we saw before, but just happening in reverse. The darkness will move away from the moon, and the brightness will come back, and we will head towards the end of this eclipse. But we still have half an hour of totality, and we still have half an hour to enjoy this wonderful reddish color that the moon has turned. On the screen there, we have put in a summary of the Danjon scale. Remember, we never know exactly what color the moon is going to turn until the eclipse actually happens. And it's always interesting to think, to try to decide what shade of red the moon has turned. Now I'm looking at this on my monitor here, and actually I'm just looking at quite a small thumbnail of this image, so I might not be the best person to judge this. I've been talking to the folks in the control room at timeanddate.com, and well, the consensus there seems to be that this is a number 3, a very kind of brick red eclipse. Also, one or two people thinking maybe a bit towards number 2. Number 2 is this slightly more rusty colored red, slightly browner shade of red. But the consensus in the timeanddate.com control room seems to be that this might be a number 3 on the Danjon scale. But we will continue to keep an eye on this over the next half an hour. Now, again, it does depend also on how you're looking at the moon and what equipment you're looking at the moon through, because different equipment have different lenses and different exposures. We have just switched here back to the Griffith Observatory. This is our other main feed for today's eclipse. This is the Griffith Observatory in Los Angeles, in California. And what you see here, maybe it's looking a little bit more like a number 2 on the Danjon scale. Maybe this image here is looking a little bit more rusty, a little bit browner. Of course, the very best way to judge it is to get outside and to have a look at it with the eye. Fortunately, something we can't do here in Japan at the moment because of the cloud cover. So here in Japan, we are relying on these great images from the Griffith Observatory and from the Perth Observatory as well. And what have we got? Yes, we now have 20 minutes to go until the end of the total phase of this lunar eclipse. Now, of course, the color. Now, the color here, of course, this is why this eclipse has been popularly referred to as a blood moon, as the moon takes on this reddish color. Of course, for this eclipse, there has been another term that has been used a lot in the media during the build-up to this eclipse, and this is the term supermoon. This is a super blood moon eclipse. Now, a supermoon is an interesting term. Like blood moon, supermoon is not an official astronomy term. It was actually coined by an astrologer back in 1979, but it has entered the sort of the popular culture as a way to talk about the moon. So what is a supermoon? Well, to answer this, we need to go all the way back to the beginning of the 17th century, and the great German mathematician and astronomer Johannes Kepler. Because until Kepler came along, everybody thought that the orbit of astronomical bodies, the paths that astronomical bodies follow, everybody thought they were circles. And this is, of course, a very reasonable assumption to make, because a circle is a very natural shape. It's a very kind of perfect shape, and everybody assumed that these astronomical bodies moved and orbited in these circular shapes. But Kepler realized that, in fact, the orbits of planets and the orbit of the moon is not a perfect circle. It is, in fact, an ellipse. It is this slightly squashed circle. And this was a very dramatic and counterintuitive discovery that Kepler made back in 1609. Now, of course, if the orbit of a planet or if the orbit of the moon is a squashed circle, that means that at some places in its orbit, it's slightly closer to the Earth. And at other places in its orbit, it's slightly further away from the Earth. So the moon is never at a fixed distance. Sometimes it's closer, sometimes it's further away. And this is what leads to the term supermoon. The original definition of a supermoon was talking about the moon when it was within 90% of its closest approach to the Earth. This was the original definition. This works out to about 362,000 kilometers. That is within 90% of the closest that the moon gets to the Earth. But as we say, it's not an official astronomical term, and other definitions do exist. Some people call a supermoon, they call it the closest full moon to the Earth in any one year. So we look at all of the full moons in one year. The full moon that happens when the moon is closest to the Earth, that is called a supermoon. And there are other definitions too. Here at timeanddate.com, we use the definition that a supermoon is when the moon is less than 360,000 kilometers from the Earth. So there are various ways of defining a supermoon. But the key thing with all of these is that a supermoon is when we have a full moon, when the Earth is close to the moon. And this means that the moon appears a little bit bigger in the sky. Not much, only about 14% bigger, but it does look bigger in the sky. The thing that is actually more noticeable with a supermoon is not the size, but the brightness. The moon is about 14% bigger, but in terms of brightness, it's about 30% brighter. So the thing that is really noticeable with a supermoon is that the moon is a lot brighter. When we see a full supermoon, it really looks a lot brighter than when the moon is further away. And today, for this full moon, the moon is relatively close to the Earth. In fact, the distance today at full moon was 360,198 kilometers. That does mean that on the original definition of a supermoon, then today's full moon is a supermoon. But interestingly, it does mean that if we take the timeanddate.com definition of a supermoon, which is less than 360,000 kilometers, and in fact, today the moon is just 198 kilometers too far away. So by our standards, it doesn't quite qualify as a supermoon. And well, that just shows you the kind of high standards that we have here at timeanddate.com. But of course, we're talking about a couple of hundred kilometers out of 360,000 kilometers. So to all intents and purposes, it really is a super blood moon today. We do have more to talk about. We also need to talk about the blue moon. That's another of the definitions, another of the terms that have been used to describe today's lunar eclipse. And we will be back in a few minutes to talk about the blue moon and why that is so interesting. So please stay with us. Please keep having a look at all of the great images that are being uploaded onto our live blog page at timeanddate.com/live. And we will see you again in a few minutes. And you are back with us on timeanddate.com's live coverage of the total lunar eclipse, where we are about 4 minutes away from the end of the total phase of this eclipse. And if we look at our live pictures from the Perth Observatory, you can see that things are starting to happen again on the moon. During this long period of totality, we had about an hour and 20 minutes of totality. The moon took on this beautiful red tint, but now as we are just 3 minutes away now from the end of totality, things are starting to change again. We can see the brightness just starting to creep in on the right hand side of the moon as we look at it here. Roger and Matt, the guys at the Perth Observatory who have been doing such a great job getting us these images, they're going to be thinking again about exposures and how to balance this, because remember, as we look at this image, the exposure that we're looking at this eclipsed moon is different to the exposure that we were looking at for the moon when it was partially eclipsed, when it had the lighter part of the Earth's shadow. Because the moon here is still fully inside the dark part of the Earth's shadow. It is a much darker moon, although we can see now it's really starting to brighten up over on that right hand side. And we're now going to start to see the more traditional gray silver color creeping in from that right hand side of the moon in a couple of minutes. And that will be the end of the total phase of this lunar eclipse. We're then back into another partial phase. And we're going to see the same thing that we saw before happen in reverse. We're going to see the light color is going to move across the moon from the right. It's going to move across to the left and return the moon to its normal color. And that is going to take just over an hour, because totality ends at 14:07 UTC, which is in about 1 minute's time. And then the partial eclipse will end at 15:11 UTC. So it's going to take just about an hour for the moon to be put back into its natural normal color. And we should say, of course, that the end of the partial eclipse is still not the actual end of the entire eclipse, because the partial eclipse, this is where we have the difference between the dark part of the Earth's shadow and the lighter part of the Earth's shadow. The partial eclipse ends when the moon leaves the dark inner part of the Earth's shadow, but the moon is still in the lighter outer part of the Earth's shadow. Now, for us looking at it from the Earth, we can't really tell any difference, because the moon is very slightly duller, it's very slightly dimmer, but really it's very difficult indeed to tell any kind of a difference. But technically the moon will still be eclipsed for another hour after the partial eclipse ends. It'll take about an hour to travel completely out of the lighter part of the Earth's shadow. But as we say, very difficult to actually see any kind of a effect from here on the Earth. So what are we now? We are just literally a few seconds away then from the end of totality. And we are now officially back into a partial eclipse phase. So that light color that we're now going to see creeping in from the right-hand side, this is going to be putting the moon back to its normal silver and gray color. And that is the end of totality for this lunar eclipse. Now we still have one or two things to talk about here on timeanddate.com. We've talked about the blood moon and why the moon takes on this reddish color during a total lunar eclipse. We talked a bit about the supermoon and how when there's a supermoon, the moon appears a little bit larger and a little bit brighter than usual. There is one more term that has been used a lot in the media during the build-up to this eclipse, and this is the blue moon. This has been the super blue blood moon eclipse, and we haven't talked about this term blue moon. Well, blue moon is yet another of these interesting terms that has an interesting history. So today, the popular definition of a blue moon is the second full moon in one calendar month. So at the moment we're in January. It's January 31st. We've already had one full moon this month. In the Americas, in North and South America, it came on January the 1st. In the rest of the world, it came on January the 2nd. So this is the second full moon in January. And by one definition of blue moon, that makes it a blue moon. But this definition is a very arbitrary definition because it does depend on your time zone. So here in Japan, for example, it is 11:10 p.m. So full moon happened here in Japan just before the end of January because we're now 50 minutes away from the end of January. However, if we jump forward a couple of time zones, if we go to New Zealand, for example, then in New Zealand, the total phase of the eclipse, and this is also the point of full moon, this actually happened on the 1st of February. So if you've watched this eclipse in New Zealand, then according to one definition of a blue moon, you haven't actually seen a blue moon because your full moon actually happened on February the 1st, not January 31st. So the second full moon in a calendar month, it is the popular definition of a blue moon, but it is a very arbitrary kind of definition. There is a more traditional definition of a blue moon, and this was the name given to the extra full moon that there is when we have 13 full moons in a year. Normally, we have 12 full moons in a year, and the full moons have names. In some years, we have an extra moon. We have 13 full moons, and in this case, the blue moon can be used as a name for that extra moon that wouldn't otherwise have a name. Now, how can there be 13 full moons in a year? Because a full moon comes around once a month. How can we have 13 instead of 12? Well, it is because the lunar cycle is just a little bit shorter than a month. The moon takes 29.5 days to go from full moon to new moon and back to full moon again. That is just a little bit less than one calendar month. So if you have a full moon near the very beginning of the year, very close to New Year, you can fit in 13 full moons in a year instead of 12 full moons. The actual technical definition of this original meaning of a blue moon was that within one astronomical season, it was the third full moon in the season that had 4 full moons. So the astronomical seasons of winter, spring, summer, autumn, when there were 13 full moons in a year, one of those seasons would have this extra moon, and the third full moon in that season of 4 full moons got the name of a blue moon. I actually think that's a very complicated definition to remember. The second full moon in a calendar month is much more simple and much more straightforward. And I think that's one of the reasons why that is now the popularly accepted definition of a blue moon. We should, of course, also mention on the subject of blue moons that very occasionally we can see an actual blue moon. Because, of course, second full moon in a calendar month has nothing really to do with the color blue. But very occasionally, it is possible to see a moon with a blue tinge, with a blue tint. And this can happen when the atmosphere is filled with particles, smoke particles or dust particles. If there are particles that of just the right size, then they can actually filter out the red light from the sun and give things a blue tinge. And we sometimes see this after volcanic eruptions. For example, after the famous Krakatoa volcanic eruption in 1883, after Mount St. Helens in 1980, there were some reports of actual blue moons being seen because there were particles in the atmosphere that were actually filtering out the red light and giving things this bluish tinge. Now, we are looking on screen at the we're back at the Griffith Observatory in Los Angeles. Oh no, actually, Anna is just talking in my earpiece here, and she says we're at Perth. Right, okay. What I'm looking at on my screen here isn't always exactly the same as what you're looking at on your screens there. Okay, oh, now we are. Now I can see. Now my screen's been refreshed. Okay, and there we are, right back at the Perth Observatory, out in the bush in Western Australia. And well, there we can see clearly we are back into the partial eclipse phase. Again, the moon is looking particularly bright on the right-hand side there. That's simply because of the exposure. The exposure is really still turned up very high there, so we can still see some of that reddish color. Very soon in Perth, they'll be turning their exposure back down again. The rest of the moon will turn dark, and we will be left once again with this very strange looking crescent moon, a very strange crescent shape, the kind of shape that we never normally see the moon take. So we will be back in our partial eclipse phase. We are going to be back in a few minutes, and we'll be taking you through to the end of this partial eclipse. As always, don't forget to keep an eye on our live page. We've got some beautiful pictures being uploaded there from around the world. Wow, timeanddate.com viewers have been taking some spectacular photos of this event, so please do check them out on our live blog page, timeanddate.com/live. And we will be back with you in a few minutes. Welcome back to timeanddate.com, where we have given you a grandstand view of today's total lunar eclipse. In fact, not only that, we have given you two grandstand views of today's total lunar eclipse because we've had these wonderful pictures from different parts of the world. So right now on the screen, we are looking at the pictures from the Griffith Observatory in Los Angeles. And you will notice that the crescent moon that we're seeing there in Los Angeles is the opposite crescent moon to the one that we were looking at before from the Perth Observatory in Western Australia. Because Los Angeles is in the northern hemisphere. Perth is in the southern hemisphere. Also, Perth is closer to moonrise. It's 10:30 in the evening in Perth. But in Los Angeles, we're getting close to the morning. In fact, the moon is going to be setting quite soon on the west coast of America. So we've got different times of day. We've got different hemispheres. The moon is taking on different orientations as we see it from these different vantage points. So as always, we're looking at the same moon. We're looking at the same shadow. But because we have these pictures from two different places, the orientation is different. And we have these kind of opposite pictures of this crescent moon. So the moon is going to be setting in Los Angeles in a couple of hours. Right now, the moon is setting in the center of the United States. If you're somewhere in the central US, then the moon has either just set or it is setting around now. You'll be having a spectacular partial lunar moon set. Now, of course, one of the interesting things is when the moon gets close to the horizon. Because we've all noticed when we see a full moon, when we see a full moon close to the horizon, either just after it has risen or just before it sets, we all know that the moon looks bigger when it's close to the horizon. When we see it near mountains or trees or buildings, it can look absolutely enormous. It's not only the moon. The same thing happens with the sun. The same thing also happens with some of the constellations that we can see. When we see some of these stellar constellations down close to the horizon, they look a lot bigger than when we see them straight up above our heads. Now there is there we have an image on the screen there now. We've got I love this image. This is a fantastic image of an absolutely enormous full moon that is rising here over the sea, and it's looking absolutely enormous. So the question is, why does the moon look so big? Well, the ancient Greeks thought that this was all to do with refraction. They thought that this was a magnifying effect caused by the atmosphere bending the light's rays. The ancient Greeks were right in that there is some refraction going on when the moon is close to the horizon. But in fact, the refraction that is occurring actually has the effect of slightly squashing the moon. Again, it's the same thing with the sun. The refraction can actually squash the sun when it gets down very close to the horizon at sunrise and sunset. So because it's being squashed, that's clearly not the reason that it's looking so big to us. So the ancient Greeks, they had a good idea, but that wasn't the correct explanation for why the moon looks so enormous close to the horizon. For the full answer to this, we needed to wait until about 1,000 years ago. In fact, until sometime around 1027, when the great Arab physicist Ibn al-Haytham, one of the great Arab scientists, published his book of optics, and he gave the first correct explanation of why the moon looks so big. He realized that it is not a physical effect. It is purely a psychological effect. Our brain interprets the moon as being much bigger when we see it down close to objects such as mountains and buildings and trees. He explained it as a psychological effect, and that has given us the name for this phenomenon of the moon illusion, because it is purely an illusion. It's all in our heads. And there is a simple way to prove this. If you look at a full moon that is down close to the horizon and is looking very big, you can take a sheet of paper and you can put the sheet of paper into a roll, so when you look through the rolled sheet of paper, the moon is just the right size to be the same size as that rolled sheet of paper. You can also take a card and you can hold it at arm's length, and you can hold it up to the moon, and you can use a pen or a pencil to mark the size of the moon on your card held at arm's length. Then you can come back a few hours later when the moon has risen higher into the sky. You can look up at the moon and you can think, well, yes, look at that. That moon is definitely smaller than when I looked at it a few hours ago down close to the horizon. But if you look at the moon through your rolled up piece of paper, or if you take your card and hold it out at arm's length again, you will be able to prove to yourself that the moon is exactly the same size, and it has all been an illusion. It's all been inside your head. So that is why we call that the moon illusion, this strange effect that makes us think the moon is so much bigger when it is down close to the horizon. Having a look back on our screen here, in Perth, Australia, we have, there we have this very strangely shaped crescent moon. It's the dark part of the Earth's shadow is moving back across the Earth's surface. The moon's familiar color is coming back. It's 14:35 UTC. We have about another 35 minutes until the partial phase of the eclipse has finished. And we will be back with you here on timeanddate.com in just a few minutes' time. And thank you very much for staying with us today. Welcome back here to timeanddate.com and our coverage of the total lunar eclipse. It is 14:48 UTC, and we are just over 20 minutes away from the end of the partial eclipse. We're looking here at the pictures from Perth Observatory in Western Australia. And as we can see, everything is starting to get back to normal. The moon has had a very eventful night. It's been eaten, it's been turned red, and now it's sort of getting spat out again. There it is with its familiar silver and gray colors. We can see beautifully there the darker gray areas. These are what were called the seas of the moon. People did used to wonder if they might be seas up there on the surface of the moon. We do know now, of course, that these are actually ancient lava flows from billions of years ago. And we can also see some of the other great feature of the lunar surface is these impact craters, and we can see some of the familiar impact craters there, including at the top of the picture here. There's that very big crater, the Tycho crater, which is named after the great Danish astronomer Tycho Brahe. And that's always one of the most familiar landmarks on the moon. Of course, it's great to look at these crater impacts on the moon. There are so many of them, of course, because the moon is geologically inactive. There's nothing to renew the surface of the moon after something has hit it and created one of these impacts. So as we look at these, we're looking at a geological record stretching back billions of years. And it shows us what has been happening on the surface of the moon over all that time. Now, you might be thinking, looking at this image, if you are from the northern hemisphere, if you're from the US or Europe or from Asia, you might be looking at the moon and looking at that big crater, the Tycho crater, and thinking, well, hang on, is that in the right place? Shouldn't that be the other way round? And of course, we are looking here at the moon from Perth, Australia. We are looking at it from the other side of the equator. So we are seeing here, if you're from the northern hemisphere, you are seeing the moon the other way round to how it more familiarly looks to you in the sky. So if you're thinking that something is wrong with the moon and that the eclipse has done something to it, then don't forget, we are looking at an image of the moon here from the southern hemisphere. How are we doing on time? We are just under 20 minutes away from the end of the partial phase of this eclipse. One more thing that we wanted to mention. A lot of people have been wondering that a total lunar eclipse is, of course, a spectacular show, and it's a beautiful thing to watch. But some people have been asking if there are any scientific uses for a total lunar eclipse. Is there anything that modern day science can learn from a total lunar eclipse? Well, the answer to this is yes. Now, the moon's surface goes through some huge temperature swings. When the moon is in daylight, when the sun is shining on the moon's surface gets extremely hot, about 100 degrees centigrade. When the moon goes into the nighttime, when it goes into darkness, the temperature goes very cold. It can go down to about minus 170 degrees centigrade. The reason for the big swing is that the moon doesn't have an atmosphere. There's nothing to control the temperature of the moon's surface, so it swings from very hot to very cold. But of course, these temperature changes normally happen very slowly because one day on the moon lasts for a very long time. In fact, it lasts 29.5 Earth days, because that's how long it takes for the moon to go from a full moon all the way to a new moon and back to a full moon again. When we see a full moon, the side of the moon nearest to us is having its daytime, it's in light. When we have a new moon, the side of the moon nearest to us is plunged into darkness. And then when the full moon comes around again, the whole of the near side of the moon is back in daytime. So one day on the moon lasts 29.5 days. And so these temperature changes from 100 degrees centigrade when it's hot down to minus 170 centigrade when it's cold, they happen over a long period of time, except when we have a total lunar eclipse. Now tonight, we have seen the whole near side surface of the moon go from bright sunlight into darkness. It's been covered up by the Earth's shadow. And this means that these extreme swings of temperature, instead of happening over the course of many days, they've happened over the course of just a few hours. And this is a very interesting thing for astronomers to study. There is a team at the Haleakala Observatory in Hawaii, and they study the lunar surface using a thermal camera, and they're looking to see how the temperature of the lunar surface changes during an eclipse, because different sized rocks, they change temperatures at different speeds. Small rocks lose their heat more quickly. Large rocks take longer to lose their heat. So by looking at the moon with a thermal camera as this great temperature change happens in just a few hours, it can reveal very interesting information about some of the features that we see on the surface of the moon. In particular, things like impact craters and some of the debris that is scattered around these craters. So as well as being an impressive show, a lunar eclipse can help us to learn more about our closest neighbor in space. That takes us up to 1457 UTC, and we have another 15 minutes of the partial phase. We can now see well over half of the moon is back to its natural color. Remember, that is still in the Earth's shadow. It is still in the lighter outer part of the Earth's shadow. It's not going to completely escape the Earth's shadow for another hour and 10 minutes or so. But this lighter part of the Earth's shadow, as far as we're concerned, looking at it, makes very little difference at all. So it really looks like it's getting back to its old self again. We will be back with you in a few minutes to take you through to the end of the partial stage of this eclipse. Please don't forget to keep an eye on our live blog page as well, timeanddate.com/live. And we will see you in a few minutes. And welcome back to timeanddate.com, where the partial phase of this total lunar eclipse is just 1 minute away from completion. We can see all we can see left of the very dark part of the Earth's shadow now is just that very small slither there on the left-hand side of the moon as we look at it from the Perth Observatory in Western Australia. And in about 30 seconds, the moon will have left the darkest part of the Earth's shadow. Now, again, we're still going to see a little bit of a darkness on that side of the moon for a few minutes after the total phase has ended, because the moon is still in the Earth's shadow. The moon is still in the lighter outer part of the Earth's shadow. If you are standing anywhere on the side of the moon that we can see now, if you look towards the Earth and the sun, you will see the Earth partially blocking the sun. Right now on the moon, it is a partial solar eclipse. The Earth is blocking some of the sun. But we can also see from this image just how strong and just how powerful sunlight is, because even though the Earth is blocking some of the light from the sun at the moment, the moon is really looking back to its original self, back to its normal color. And when we look at this penumbral eclipse, this is the eclipse we see now with just the lighter part of the shadow. It's still a lunar eclipse, but it's a penumbral eclipse. And actually, it's very difficult to tell any difference between a penumbrally eclipsed moon and just a normal moon. And that is 1512 UTC. And the partial eclipse has ended. The moon is now fully out of the dark part of the Earth's shadow. And the moon will now spend the next hour or so making its way out of the penumbra, out of the lighter part of the Earth's shadow. But certainly for us on timeanddate.com, that is the end of the real drama for today's broadcast. We are going to go back to the timeanddate.com control room in Stavanger, Norway, where everybody's been working so hard today and coordinating all of these pictures from around the world and keeping our live blog so full of updates. Anna, how has it been there in Stavanger?
Oh, it's been pretty intense. We've been communicating with Perth, and they've been adjusting their exposure and the cameras, and we've been flipping around between Griffith and Perth and talking to you in Japan. So it's been a lot of fun, and the time went really quickly.
Wow, it really did. And we have to say, first of all, we've been very lucky with the weather in Perth and Los Angeles. In fact, I mean, we had perfect skies there for the duration of this eclipse.
Yeah, we've been really lucky with our images. There are a lot of variables that can go wrong. There's technical issues, and there's snow. We had snow outside here in Norway. Unfortunately, it's still light, so we can't see any of the eclipse. And we're happy that it went as smoothly as it could go with all the technical stuff that could go wrong.
It really did. It really did. And I was delighted to see that on the live blog page, we did manage to get up on the live blog page a photo of the eclipsed moon from here in central Japan, where I am. Unfortunately, it's been a difficult eclipse here. We've had all this cloud cover. We're supposed to have snow coming shortly here in Japan, but we did manage to get one, well, rather cloudy image of the moon, which is up on the live blog page. So, well, there you go. That's our contribution from Japan.
And hopefully the people that have been watching us, and some people might have been going out and looking up the sky, maybe they've caught a glimpse in between clouds. I guess in the US they had to get up really early to be able to see this, and it's not always that easy to get out of bed when it's in the middle of the night, is it, Graham?
Well, that's the thing. So, I mean, here in Japan, in Australia, it's been a case of staying up late. Where are we now? We're now midnight in Japan. We have now made it into February here in Japan. So yes, here it's been a case of staying up late. In the US, that's right. It was a case of setting the alarm clocks and getting up early. And places like poor old Hawaii, they fell right in the middle of the night. So they have the tricky thing of whether to stay up late or to get up early. I don't know what their strategy was.
They probably had the luxury of seeing the whole thing, though.
They did indeed get to see the entire event. So
and we mustn't forget our friends in Perth that have been working so hard for us. Matt Woods and Roger Groom, they've really worked hard for us up the other end and had a lot of fun doing it. I've been getting Skype messages in every time they've been changing batteries in their camera and re-exposing and changing from video mode to picture mode, and it's we've had some nervous moments doing this.
Yeah, no, they've done such a great job. And let us not forget that they got us off to a great start today with that amazing picture of the moon rising through those gum trees.
Yep.
Down there in Perth, which was a very well, that was actually a wonderful start to the show.
And hopefully we have some images to show. I'm going to look over my shoulder here at the command center, and I'm getting a nod. So we'll try to get those pictures up now.
Okay.
Yeah, we've got some pictures. Can you see them, Graham?
I can see them. Yes, yes, I can see these are wow, these are some wonderful tinted red moons here. Wow, these are spectacular. We are seeing actually the very slightly different shades of red in each of these. It really does depend on which part of the world, what kind of equipment you're using. It does give it all a slightly different phase. There's a beautiful partial eclipse phase there. Oh, again, these are wonderful images. Yeah, fantastic there. You can see the partial eclipse, and actually, yeah, we can start to see the red color was coming in on that partial eclipse picture there. These are tremendous.
And did we actually see a blue band like you can sometimes see on a total lunar eclipse? Or do we just get the light of it?
No, I didn't see that here. Now, again, I have to say that I have been watching this on quite a small screen here, so it was possible. It was possible that that I missed that there. Maybe some other people with a bigger image on their screen may have had more success with that.
No, we didn't see much of it here as well. Why does it sometimes get a blue band?
The blue band, this can be caused when the moon is passing, or the light is passing through the Earth's atmosphere, and as it goes through certain parts of the Earth's atmosphere, for example, like the ozone layer, it can filter the light in different ways and send slightly different wavelengths towards the moon. So you do occasionally see these little bands of color as the sunlight goes through different parts of the Earth's atmosphere.
Okay. And so we've seen through these images now. I think everybody's seen them. And we might want to go back to Perth. And there we have the moon. It looks pretty normal to me, Graham.
You know, the thing, Anna, that if we think back to our broadcast of the total solar eclipse in America last year, we were looking at pictures from the football stadium at Western Kentucky University. And we were very struck then at the moment of totality, when the moon covered the whole of the sun. Things went dark very quickly. But at the end of totality, when the moon started to uncover the sun again, although there was only a very thin crescent sun that could be seen from Kentucky, everything got bright very quickly indeed. Even when there's just a very small amount of sunlight, it is amazing how much energy the sun gives out. And we're seeing exactly the same effect today on the moon. Right now, everywhere on the moon that we're looking at is experiencing a partial solar eclipse. But it really does look normal, because even when it's just a fraction of the sun's rays that is reaching the moon's surface, it's still giving an awful lot of light and an awful lot of energy to the moon. So yeah, it is very striking how the moon does look very much back to normal, even though the eclipse is not fully finished yet.
No. And there must be, there's about 100 people in Perth looking up at the sky, laying in the kangaroo eating grass there and enjoying the spectacular view of a beautiful moon as well, a beautiful full moon.
Oh, and I tell you, anybody that has been out looking at it in Australia, I'm sure they've had a much more pleasant time than anybody here in Japan who's been outside trying to have a look. I've been out a few times here to have a look, and I have had to put on the coat and the hat and the gloves and everything just to pop my head out and have a quick look. Yeah, I'm sure they've had a much more pleasant evening down there in the Australian summer night, enjoying this eclipse.
But this is not the last lunar eclipse this year, is it?
No, it's not. And in fact, we do have many more exciting events that are coming up in a sky near you. And well, we've got the list is up on the screen here. We are actually into a very nice run of total lunar eclipses. The next one will be happening, we can see here, July 27th and July 28th. So after sunset on July 27th, or before sunrise on July 28th. This will be a total lunar eclipse that will be visible across Europe, across Africa, across Asia, and across Australia again. So if you're in Europe and you missed today's total eclipse, you will have a chance in 6 months' time to have a look at the next one. 6 months after that, we have another total lunar eclipse. This is happening on the 20th and the 21st of January. This is going to be visible from North America and South America, and again from Europe and from Africa. So we have 2 more total lunar eclipses coming up. And then the focus shifts back more towards solar eclipses. Although lunar eclipses and solar eclipses are very different things, they are, of course, all part of the same Earth, Moon, Sun system. So we do have times when we seem to have a lot of solar eclipses, a lot of total solar eclipses. And then we have times when there are more.
They come in seasons, right?
That is correct. They come in seasons. As we know, the moon goes around the Earth once a month. And of course, you might think that we should get an eclipse every month. You might think we should get a lunar eclipse every time there's a full moon, because we have the Earth in between the moon and the sun. And you would think that we might get a solar eclipse also every month, because when there's a new moon, that's when we have the moon is between the Earth and the sun. But we don't. Eclipses are separated by about 6 months. The reason for this is that we talked before about the moon's orbit. It's not a perfect circle. It's elliptical. Something else that is special about the moon's orbit is it's slightly tilted compared to the Earth's orbit around the sun. So normally, when there's a new moon or a full moon, in fact, the Earth, moon, and sun are not perfectly aligned. That the moon is either just a little bit above the sun or a little bit below the sun. But every 6 months, everything comes together, and full moons and new moons happen at the time that the moon's elliptical orbit is crossing the orbit of the Earth around the sun. And this produces these lunar and solar eclipses about 6 months apart. In fact, it's slightly less than 6 months. We can't really see it on this. Well, we can actually. Today is January the 31st. If we have a look into if we look into 2019, then we see that we have an annular solar eclipse on December the 26th, 2019. So it's happening around the same time of year, but actually it's happening slightly quicker than every 6 months. So these eclipse seasons, they do actually gradually shift through the year, and overall they always come at different times of the year. So yes, we have this great run of total lunar eclipses coming up, and then we are back into solar eclipses. We have the total solar eclipse on July the 2nd, 2019. This will be a total eclipse across the southern Pacific Ocean and across Chile and Argentina. This total eclipse will be finishing just to the south of Buenos Aires at sunset on
I just have to
July
interrupt you. I got a message from Roger doing the last final filming in Perth, and they've got kangaroos grazing on the lawn as they're looking up at the full moon. So they're having quite an idyllic time there.
Wow. Okay. That is wow. That's a very Australian end to our coverage, isn't it? Yeah.
So we're fading out. We've got another couple of minutes of the full moon during the penumbral eclipse, and then we're going to be ending our broadcast quite soon, won't we, Graham?
Then we are, yes. And we want to just say a very big thank you again to the whole team at Perth Observatory for getting us these fantastic images today. And that's been quite a show that they've given us there at the Perth Observatory and at the Griffith Observatory in Los Angeles. And
I think we'll say, well, it's good night to you, isn't it, Graham?
Well, it's good. It's midnight here in Japan, so it's good night from me in Japan.
We'll just fade out. We'll say goodbye and see you next time, and we'll just enjoy the last few minutes of the moon.
Wonderful. See you next time.
See you. Thank you.